Welcome back, dear students. Let's continue with question number 6 today, which says in the given figure ABCD is a rhombus. So look at this ABCD. So this diagram is a rhombus, okay, with angle A equals to 67 degree. If DEC is an equilateral triangle, now here DEC is an equilateral triangle, we need to calculate angle CBE. Okay, so CBE means we have to calculate this angle, okay, and DBE, okay, so we need to calculate DBE, that is this angle. So let's see how to calculate these two. Right, so given that ABCD is a rhombus with angle A equals to 67 degree. Now what are the properties of rhombus? So properties of rhombus is this angle, the opposite angles will be equal. So angle A and angle C will be equal, and similarly angle B is equals to angle D. Opposite angles are equal, okay, all the sides will be equal to each other, all the sides will be equal to each other, and the diagonals bisect each other at an angle of 90 degree. Okay, so these are the properties of rhombus. Now in the rhombus we have, as I said, angle A and angle C will be equal, okay, and the value of angle C also becomes 67 degree in the same way, okay. And we have another property, I'm sorry I forgot to tell you that the consecutive angles, okay, so when you add the consecutive angles then their sum is going to be 180 degree. So that's why angle A and angle D, they being consecutive angles, their sum is going to be 180 degree. Okay, right, so you know that angle A is 67, so bring this 67 out here, you get 180 minus 67, so the value of angle D turns out to be 113 degree. Okay, so we got this angle D to be 113. So in the similar way we are going to have angle D equals to angle B, isn't it? Okay, so this angle is also 113 degree. So that's why I have written angle ABC is equals to 113 degree, because it is in the opposite angle of D. Fine. Now consider triangle DBC. Okay, so just look at DBC. So I'm talking about this triangle. Okay, so in this it is given that DC is equals to BC or CB, because they are sides of the rhombus, and you know that sides of the rhombus are always equal, right? Okay, now in that case this becomes, see, if these two are equal then this triangle DBC that we are talking becomes isosceles triangle, isn't it? So it becomes isosceles triangle. So that's why we say that, see, if this is isosceles triangle then the base angles, that is CDB and CBD, that is this angle and this angle, both of them are going to be equal to each other. Okay, and also we know that the sum of the interior angles will be equals to how much? 180 degree. Okay, and you know that this angle BCD, we can say angle C or BCD, this is 67 degree. Okay, so in place of this I'm going to write 67, and here see these two are equal. Okay, so that's why what I can do here is BCD is 67, so bring it out here, 180 minus 67 becomes 113, and here in place of CDB I have written CBD. Both are same, right? So CBD plus CBD becomes 2 times CBD. So from here CBD turns out to be, bring this 2 to the denominator, so 113 by 2 becomes 56.5 degree. Let me repeat once again. So 2 goes to the denominator, so 113 divided by 2 is 56.5 degree. So this is the value of CBD, and since CBD and CDB both are equal, so that's why the value of CDB also becomes 56.65 degree. Okay, now consider DCE. Okay, so DCE means this triangle, upper triangle. Now this is equilateral triangle, it is already said, right? So this is equilateral triangle, so that's why all the sides will be equal to each other. So in the same way I have written EC equals to CB, EC equals to CB. Okay, kindly make a note of this. If CD and BC are equal, then obviously EC will be equals to BC, isn't it? Right? Okay, fine. So that's why you know DCE is an isosceles triangle again. Okay, so kindly look at this DCE. This is actually equilateral triangle, but we can call it isosceles also because two sides are also equal. So similarly, what we can have here is we can have CBE is equals to CEB. Okay, CBE is equals to, I'm sorry, just wait a minute, I have done some mistake, I guess. Yes, kindly make correction. Okay, so this is not triangle DCE. Okay, this is BCE. Okay, in place of D it is B. Okay, so I'm going to talk about this triangle. Okay, BCE. Now kindly make a note of it. So in this two triangle EC and BC, they are going to be equal. I have already told you, or I have already given you the reason why EC and BC are equal. So that's why this triangle becomes, okay, so this is not DCE. Kindly make correction of this. As I said, this is going to be BCE. Okay, so BCE becomes isosceles triangle because EC and BC, they are equal. Okay, similarly in that case CEB and CBE, this angle and this angle, they are going to be equal. Okay, so again all of you know that what happens here, some of the interior angles will be equal to each other. Okay, now from here we have, kindly look at this carefully. Okay, so from here let's find out what is the value. Okay, so we have CBE plus CEB. Since both of them are equal, in place of CBE I have written CEB, I have written CBE. CBE plus CBE is 2 times CBE. Now what is BCE? Kindly look at this. Okay, so this is how much? So this is 67. And how much is this? This is 60 because equilateral triangle, right? So in equilateral triangle, you know that each angle is 60. So 60 plus 67. BCE is 60 plus 67. When you get both of them out here, you get 180 minus 60 minus 67, which is going to be 53 degree. So from here, bring this 2 to the denominator, you get 53 by 2, which is 26.5 degree. So this is the value of angle CBE. Now DBE, that's what we need to find, right? So DBE, we need to find this angle also. So let's find how to do that. So from 1, so let's look at 1. Okay, so from 1, what you have is CDB is equals to 56 point CDB. Kindly look at this. CDB is equals to, I'm sorry, CBD, no? Yes, CBD. So this entire angle is equal to how much? 56.5, right? And just now we got this much, this angle. Okay, so we can write CBD as what? CBE plus DBE, right? That's what I have written in place of CBD. Now CBE is 26.5. Bring this out here, you get 56.5 minus 26.5. So the difference turns out to be 30 degree. And your second answer turns out to be 30 degree in this case. Pause the video and note down the solution. Let's move to the next question. So this question is entirely based on the simultaneous equations. Okay, so simultaneous equations is very easy to solve. All of you are quite aware of this now. Okay, so for the first one, so you need to find the values for x and y in both the cases. So since they are parallelogram, you should know the properties of parallelogram. Okay, now ABCD is a parallelogram, means the opposite sides will be equal. That is, AB will be equals to DC and AD will be equals to BC. That's what is written out here. Now measurements are given. AD is equals to BC, right? Okay, so we have AD is, okay, AD is given to 4y and BC is given to be 3x. So 4y is equal to 3x. So bring everything out here, you get 3x minus 4y equals to 3. So call this as equation number 1. Simultaneous equation, if you remember. Now similarly, you know that AB is equal to DC. AB is 4x and DC is 6y plus 2. So from here, from this, what you get is, you get 4x minus 6y equals to 2. So call this as equation number 2. Now solve 1 and 2. I am not solving that. Okay, so when you solve that, you get your values to be x equals to 5 and y equals to 3. So the answers will be x equals to 5 and y equals to 3. Now see, this one I am not going to do. I will just give you hint here. Okay, so here number 2. So you know that the opposite angles will be equal. So if the opposite angles are equal, then this much will be equals to 7y. And another property says that how much ever is this angle, the value of this angle will also be the same. Now, but this value is not given to us. Is this given? No, this is not given. Okay, so what you can do here is, you can do one thing. You know that in parallelogram, the sum of adjacent angles will also be 180 degree. So that means this plus this should be equals to 180 degree. See, for the first equation, what you can do is, you take this angle equals to this one. You get equation number 1. Okay, so for second equation, for getting second equation, what you can do is, sum of this angle and this angle will be equals to 180 degree. So from there you get second equation, solve 1 and 2 and get the value of x and y. Okay, so you may pause the video and note down the solution. Okay, so let's take the last question for the day. So the angles of a quadrilateral are in the ratio 3:4:5:6. Show that the quadrilateral is a trapezium. Okay, so trapezium, all of you are quite aware of the shape of trapezium. Now, if you talk about the properties of trapezium, what you have is this side, okay, any two sides will be parallel, and the sum of the adjacent angles formed by the parallel sides. So that means I am talking about this angle and this angle. Okay, so sum of this angle and this angle, it will be 180 degree, and the sum of this angle and sum of this angle will also be 180 degree. But we cannot say whether this is the sum of this angle and this angle, they are 180 or not. Okay, so kindly observe this again, the sides which are parallel. Okay, so the angle made by the non-parallel sides with the parallel sides. Okay, so the non-parallel side is AD. So if AD makes angles, angle D and angle A with the parallel sides, their sum is going to be 180 degree, and similarly angle C and angle B, when you add them, you get 180 degree. Okay, so the angles are given to be in this ratio. So let me take the angles to be 3x, 4x, 5x and 6x. Now you know that this is a quadrilateral, and sum of the interior angles of a quadrilateral is 360 degree. So that's why when you add all the angles, you get 360 degree. Now from here you calculate the value of x, which turns out to be 20 degree. Okay, so therefore the angles are, so the 4 angles are out here. So 3x, that is 3 into 20, 60, 4x, that is 4 into 20, 80, 5 into x, 5 into 20 is 100, 6 into 2, that is 6 into x is 120. So these are the respective angles. Now we will search for the angles whose sum is going to be 180 degree. Just look at this, 60 degree and 120, sum is going to be 180, and the rest of the angles will also add up to 180 degree. So that's why, since this happens, thus the angles of this trapezium form a trapezium, and that's what we need to prove, right? Okay, so you may pause the video and note down your solution, and today we'll do only this much. Thank you very much.